Yeah. We'll do that equation. So I'm going to make some chlorine gas so you can see it. And then I'm going to bubble it through potassium iodide and potassium bromide. Now, if I've got chlorine gas, is it going to displace the iodine? It's going to displace the iodide ion. It's going to become potassium chloride, and I'm going to see what colour as the iodide ion loses its electron and becomes iodine. It'll go brown. And my potassium bromide, the ion is colourless, but when I displace it with the chlorine, what's going to happen to the bromide ion? It's going to lose its electron, isn't it? It's going to become bromine. And what colour is bromine? Red. Okay, let's see if that happens. First of all, I've got to make the chlorine. And at no time will my... I need a spatula. I need a spatula. Unless, of course, there's a spoon in there. Coming back. No, it's not. Are you filming this?
Yeah.
Oh my gosh. Right. This could be on one news and whole class load of year 12 students succumb to chlorine gas. Yeah. Okay, we'll just make it. Right. So what I'm going to do is I'm going to take this off here and I am going to put in some potassium permanganate, but it's not obviously in water. So it is a crystalline substance. So we'll get a bit of that in there. Okay, that should do it. Right, I've got hydrochloric acid concentrated. And I'm going to just take the lids off these. Can you guys see? You need to get where you can see. Because I'm in your way. My big fat body is in your way. Now if this doesn't work, we'll go... Just to see what I need.
Yeah.
It's just a lower the floor, but to be a little
Yeah.
more comfortable. It's like machines now.
Oh yeah.
At least it's working.
I've got some colour on this.
At least covering your mouth isn't going to do much. You have to stop breathing.
Sorry, just take a moment, take a spell. So I'm making chlorine gas. Where's the chlorine coming from? I've got hydrochloric acid and permanganate.
Hydrochloric acid.
Yeah, it's taking the hydrogen off the hydrochloric acid. That's oxidation, isn't it? Because that's what permanganate... I'll take the glass one. Okay. I just feel a bit better. Okay,
Do you want to pop a cookie with that?
No, she's good. She's good.
She's good?
But let's not complicate this.
Okay, you don't.
Okay. I grew up with mouth pipettes. I know. Yeah. I was just going to bring it because I want it close to you. Yeah. Okay, so I'm going to pull that down. Because as soon as this hits that, I'm going to get chlorine gas because permanganate's going to oxidize the chloride in hydrochloric acid. Whip off its electron because permanganate always does that. It always oxidizes something. Okay. We'll see if that's enough. I'm trying to use minimal quantities. So that's chlorine gas coming out as permanganate is oxidizing the chloride in hydrochloric acid.
Space first.
Yeah.
Now we're going.
Now we're going.
Now we're going.
Now we're going. Now she's going. She's blowing. We're seeing a colour change now. It is going a browny, iodine-y sort of colour. And we keep going. And we keep going. And we keep going. Can you see the brown?
Yellow.
Well, it's sort of brown. It's very dilute brown. So I'm going to add some more hydrochloric acid to my little nest of vipers, no, my permanganate.
Oh wow.
See the iodine? It's being oxidized by the chlorine. So the iodide is coming out of solution and being iodine. Now is that brown?
Yes.
Are we all agreed?
Yes.
Fabulous. Right. Now I'm going to do the same to potassium bromide. I might just need to add a bit more juice. Hydrochloric acid. She says it, she sprays it everywhere. You'll be pleased you're behind a rabbit-proof fence. Yeah, I know it looks yellow. I can hear it. I can hear you. How do I know the permanganate isn't all reactant?
Because it hasn't discolored.
It hasn't gone colourless, has it? So I know I've still got permanganate. Trying to get a reddish colour for you to see it. It's an orangey kind of red. See if it's reading up.
I don't think it's quite real.
Getting rid of? Right, I'm just going to actually show you a bit of chlorine gas, just so you can see it's green, because I don't think you've seen that yet. So we all agreed that that's it looks orange, doesn't it? But it isn't orangey red. It's still a little bit dilute. Okay, I'm now going to show you what chlorine gas looks like. If I can get enough. If I can get enough. It's quite pale.
Right, you just put a normal bang on the conical flask.
What's that?
Right, you just get a normal bang on the conical flask and picture it there.
Yeah, well, you can see that there. Yeah. Okay, I'm holding that up so you can kind of see from the white background it's a slightly greeny gas. Certainly not, but you need quite a bit of it to see the green colour, and I don't want to make too much of it because it is nasty stuff. And it was quite nice to get it to change into chloride ions. That's why I shove it in there, because then the chlorine gas no longer exists, it's chloride ions. which are pretty harmless. Okay, so I'm doing a post-purge. So a post-purge is for 20 minutes after we've done the experiment, it's still pulling air in to make sure every last molecule of chlorine is gone. Okay, so let's have a wee look at that reaction.